Welcome to Algeomulus Prep Academy. Today's lesson is finding intervals of increasing and decreasing using the first derivative test. The steps for the first derivative test can be summed up like this. The first step is to take the derivative of the function f. The second step is to find the critical points. Critical points are where f prime equals 0 or where f prime equals undefined. The third step is to graph the critical points that you found on an f prime number line. The fourth step is to test between these critical points to see if f prime is positive or negative on these intervals. The final step is to interpret the f prime number line. If f prime is greater than 0, then that means the graph of f is increasing or rising. F can look like any of the three graphs displayed on the screen. If f prime is less than 0, then that means that the graph of f will be falling or decreasing. Examples of this will be displayed on the screen. Example 1. f of x equals 3x squared plus 7x plus 19. Find where the function increases and decreases. Step 1 is to take the derivative of f of x. To do this, we can use the power rule. This gives us f prime of x equals 6x plus 7. Next, we need to find the critical numbers. In order to do this, we can set f prime equal to 0 and solve for x. When doing this, we get x equals negative 7 over 6. Then we find where f prime might be undefined. Since f prime is a linear function, it will never be undefined. Now we can make a number line with f prime on the top and x on the bottom, labeling the critical numbers. In order to find where f prime is positive or negative, we can plug in a number from either side of the critical number. Here, we let x equal negative 2 and substitute it into f prime of x. This gives us negative 5. Because negative 5 is negative, we can label the above number line with a negative sign. Similarly, we can let x equal 0, which makes f prime equal to 7. Because 7 is positive, we can label the graph with a positive sign. Since we know f prime is less than 0 from negative infinity to negative 7/6, we know it is decreasing on this interval. Similarly, since we know f prime is greater than 0 from negative 7/6 to positive infinity, it is increasing on this interval. By interpreting this number line, we can determine the general shape of the graph of f. Since f prime is less than 0 on negative infinity to negative 7/6, f will be decreasing. Because f prime is 0 at negative 7/6, the graph of f will stop. Lastly, because f prime is greater than 0 on negative 7/6 to positive infinity, the graph will begin increasing. Example 2. f of x equals 5x cubed minus 2x squared plus 10. Find where the function is increasing and decreasing. First, using the power rule, take the derivative of f. Once this is done, we can factor out the x, which gives us f prime of x equals x times 15x minus 4. We can now find the critical points of this function. Set f prime equal to 0 and solve for x. This gives us two solutions, x equals 0 and x equals 4/15. Then find where f prime of x might be undefined. Since f prime is a quadratic function, it will never be undefined. We can now make a number line labeling the critical points. To test for intervals where f prime is positive or negative, we can now plug in a number on either side of the critical points. To do this, we will use x equals -1, x equals 1/5, and x equals 2. When substituted in, f prime of -1 equals 19. Because 19 is a positive number, we will write a positive sign above this place on the number line. F prime of 1/5 is -1/5. Since this is a negative number, we will write a negative sign on this interval in the number line. Lastly, f prime of 2 equals 52. So we will label this interval using a positive symbol. F is decreasing on the interval 0 to 4/15 because f prime is less than 0. F is increasing on the intervals -infinity to 0 and 4/15 to positive infinity because f prime is greater than 0. Because the number line of f prime goes from f prime is greater than 0 to f prime is less than 0 to f prime is greater than 0, the graph of f will increase, stop, decrease, stop, and then increase again. It will look similar to the graph displayed on the screen. Example 3. If f prime of x equals 4x over x squared minus 3, find where the function f of x is increasing and decreasing. We can find the critical points now. Set f prime equal to 0 and solve for x. This gives us x equals 0. In order to find where f prime equals undefined, we must set the denominator of the function to 0. When x squared minus 3 equals 0, x equals plus or minus root 3. We can now take all three of these critical points and place them on an f prime number line. We can now test between these intervals to see where f prime is negative or positive. In order to do this, we can use the values x equals -2, x equals -1, x equals 1, and x equals 2. Since f prime of -2 equals -8, we can place a negative symbol on this interval of the number line. F prime of -1 equals 2, so we can place a positive symbol on the number line. F prime of 1 equals -2, so we place a negative symbol. Lastly, f prime of 2 equals 8, so we can place a positive symbol. F is decreasing on the interval -infinity to root 3 and 0 to positive root 3 because f prime is less than 0. F is increasing on the intervals root 3 to 0 and root 3 to positive infinity because f prime is greater than 0. Because f prime is undefined at plus or minus root 3, the graph of f can have many possibilities. Because we do not know what the original function is, the graph can either look like what is displayed on the screen right now, or what is displayed on the screen next. These are not the only two possibilities, but because we do not know the original function, we cannot determine for sure what the graph actually looks like. If f of x was bounded by the interval -10, 10 inclusive, the graph of the function would look like this. We can say that f prime is negative when x equals -10 because when we previously tested on the interval -infinity to root 3, we came to the conclusion that the entire interval was negative. Because -10 is on this interval, we know that f prime is negative. We can apply the same logic to when x equals 10. Because we came to the conclusion that the interval root 3 to positive infinity was a positive interval, then f prime must be positive when x equals 10. So, if f of x was bounded by the interval -10 to 10 inclusive, then we can come to the conclusion that f would be decreasing from negative 10 inclusive to negative root 3 and 0 to root 3 because f prime is less than 0, and f would be increasing from negative root 3 to 0 and root 3 to 10 inclusive because f prime would be greater than 0. Thank you for watching Algeomulus Prep Academy. We hope to see you for the next lesson as well.